So in this video we're looking at how to write up your aim, equipment and method parts of an investigation. So first of all, your aim, you have to describe what you're investigating, what you are investigating. The essence of the aim is, in physics usually you're controlling a whole bunch of things so that you can test one variable against one other variable. That's what we're dealing at a high school level anyway. So for instance, you might want to control the length of a pendulum, which is then your independent variable, and the independent variable is independent variable is the one that is independent of any of the other variables. So you change the independent variable and it produces changes in other things. So your aim will say, I want to change the length and see what happens to, for instance, the period of a pendulum. And the period is then, and everything else is kept constant. So your period is then dependent because it's dependent upon what you change with the hour, with the length. Okay, so your full aim, what you would write for the aim, I'm not going to write this down, the aim would be to investigate the changes in the period as I change the length. And you might expand that to come up with a mathematical relationship between length and period for a pendulum. Okay, and if you want even more investigation, you can get into that, but I'm not going to dwell on it. That's the essence of it. Keep it short, keep it brief, keep it to the point. Okay, investigating what happens to the period as I change the length and coming up with a mathematical relationship. The equipment, you would just maybe list all of the equipment that you're using. In a lot of cases, it's actually unnecessary, I feel, this is just my personal style, to write down the equipment. So it can be that your equipment is very clear and obvious in the method. You know, the essence of why you're writing these things up is important, and it's because you want somebody else to be able to do the exact same experiment and produce the exact same results. So that's why you're so precise in describing your method and everything that you do. So as far as your method goes, let's just move this up a little bit. What would you include in your method? Okay, so for your method, one of the really important things to include is a diagram. And if you're dealing with the pendulum, you might want to include such specifics as what angle is, here's your pendulum, what the angle is. You want to label all of these parts and explain what they are. This is the ceiling or the retort stand, or you might draw it actually as a retort stand with a clamp. And you only need rough well, when I say rough diagrams, they don't need to be detailed diagrams, but they still need to use a ruler and be carefully drawn and labelled and everything like that. So and you also should show that a period is there and back again. So one period is there and back. All those sorts of things you should show in your diagram where possible, because a diagram, you know, a picture says 1,000 words. A diagram is much quicker and easier to explain things than writing it all out, and your teachers will hate marking it. And if you can get straight to the point and it's very clear and obvious from there, then that's good. So a diagram's essential. Other things you should say in your method are which ones you're controlling and which ones you're measuring. So that goes back up here to our dependent and independent variable. I don't think you necessarily have to use the words independent variable is and dependent variable is, but it's good to identify which you're controlling and which you're measuring. That's really important. Okay, when you're getting to the heart of the purpose of an experiment, getting to the investigation, and for someone to copy it and repeat your results to show that this is a physics law of the universe or whatever, you need to be able to clearly show which ones you're measuring and which ones you're controlling. Okay, so the other thing is you're going to write your variables, your independent and dependent, and also all the ones you're keeping the same. So you've got these ones, and you've also got the ones you're keeping constant or controlled the same. And that could be one or two, it could be heaps. It could be that someone comes along 100 years from now and says, hey, no one's been controlling this variable, I'll control that, and they get totally different results. Very interesting. Okay, what else do you need in your method? Probably a step-by-step details showing your accuracy techniques. Okay, your accuracy improving techniques. Accuracy. Okay, my spelling's hard when I'm talking and thinking and moving ahead of the pace that I'm writing. Accuracy techniques. So you might do a repeat and average. With a pendulum, you do 3 trials and divide by 3 to get your average. You might do multiple measurements. And all these accuracy techniques I've talked about in some earlier videos on how to use a stopwatch and how to use a measuring cylinder and so forth. So I won't detail heaps of them here. You can talk about with the pendulum in particular, and anything that's undergoing oscillating motion, that the motion is kept in a steady motion in a single plane of movement, if that's what your intention is to measure. So you don't want this doing a conical thing, you want it going back and forth in that nice pendulum line. Okay, and that more or less covers your method. Pretty much the rule is anything that you need to include for somebody else to be able to read it and copy it, and you can't assume anything, especially not those accuracy techniques, and especially not that they'll know how to set it up. So a diagram is essential rather than having to describe it in thousands of words exactly what your setup is. Okay, and yeah, those variables state pretty clearly in your method and your step-by-step what you're measuring, what you're controlling, and that'll more or less cover your method.